topic too much because it confuses people as to my position on evolutionary biology. But before we move on, I think that evolutionary biologists paint really good pictures about why the populations or the distribution of alleles are the way they are. I don't doubt any empirical data that they use to create these narratives. I just think that at the least, natural selection is unneeded as a theory or mechanism or explanation in evolution. You could perfectly do it well without it. I don't think that what Darwin discovered was any particular explanatory thing with an explanatory power in evolutionary biology, even though it seems like it is. But that's my position. Now, I don't know how much I don't know where we want to go from here. I gave the argument to Blitz. I gave the argument to Peterson. I'll just get on with it. It's not very convincing. Okay. It's a philosophical argument against natural selection. I don't use any particular empirical data to show the flaws in it. And so thus if you're scientifically, minded, it's philosophically motivated. So that's already kind of a barrier. But what do you want to
We might have a problem here. Yeah. So I guess I don't know, Blitz, do you want to say anything?
So Danny and I have actually already had this conversation. I'm perhaps somewhere between the two of you, but I'll let you guys do your thing. I'm still heating up food anyway. And then maybe after you give your position, then I'll give my middle of the road enlightened centrist position.
Okay, cool. So I don't have a philosophical argument for you. Not exactly, at least. I mean, I plan on going about it by way of metaphor and using my Galton board to try to help me out. I don't know if that counts as I don't think that counts as philosophical. But before we do anything, I guess what I want to do is run down the list of the basic ideas, like premises behind natural selection, and see if you disagree with any of them, because I don't think you will. And then it'll be kind of like, well, and I know about Fodor's arguments or whatever, so maybe like we'll get into that next. But I'm gonna find it, I don't know, it's gonna be weird if you agree down the line but then say but natural selection isn't the mechanism and wasn't particularly useful or didn't discover anything new or whatever. So
I have a definition that I use. I don't know if you want to hear that first or you want to go through your list.
The definition of natural selection
that I use, yeah.
Go ahead.
Okay. I mean, and at least I should say the definition that Fodor uses, which I thought, here it is. Okay, this is Fodor's definition of natural selection, and this is the one that I'm fine to use. Creatures are selected for the relative fitness of their phenotypic traits in their ecology. Phenotypic traits are selected for their role in causing increases of fitness according to the following principle. If in a certain ecology, creatures that have phenotypic trait T are more fit than creatures with T2, then all else being equal, creatures with T1 will be selected for in preference to T2.
If creatures with trait T, which has greater fitness than T2, exist, then T will be selected for?
All else being equal.
Okay. 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 Is that the whole thing?
Yeah, that's the definition of the one that Fodor explicitly articulates.
Okay. That's, I mean, it's not bad. I mean, it's completely different than what I was going to say. So like the way I run through these are, most organisms don't survive to reproductive maturity. So do you agree or disagree with that?
Most organisms don't survive to reproductive maturity? It seems. I mean, I'm fine to say that's true. I mean, I don't. It seems like that seems true.
Yeah, well,
Is it like the case of like you have baby spiders and only like 10 of them out of like the billion of them survive? And yeah, okay, yeah.
yeah, and it's even worse for like plant seeds and things like that.
Mhm.
Um, um, so because of that, organisms produce vastly more um, offspring than can ever hope to reach reproductive maturity. That's sort of the second part. There's like five of these. I'm probably not going to remember the five exactly, but that's fine. Um, so because of this, there is extreme competition for resources among organisms.
So the first fact you're saying explains the second fact.
Not really. This is just kind of this just lays the framework for it. These aren't like if then statements or anything like that.
Okay, because you said because of that, and so that's an explanatory relation that I'm assuming.
Oh, okay. So, yeah, I would guess I guess it's the reason that insects produce so many offspring is because most of them don't have. I mean, it's weird because this assumes that there's something making this happen, which is a very incorrect way of viewing evolution, but that's just the way we use terms. So, yeah, I think you are correct in your analysis. The reason that we
Maybe I'm not.
have
Look,
that
we
that
can.
organisms produce so many offspring is because most of them won't survive to reproductive maturity.
Okay, well, I don't know what you want to do because they don't. A lot of people that are watching right now don't even know my problem with natural selection. Okay, um, but there are, but you've heard the video. It's a very complicated, boring explanation, and it will kill your life. Right? So
Possibly.
I don't know if you. I think a lot of people would want to know at least the direction I'm coming from, and I think it's very important to illustrate what would happen. Let's say I'm right. So what? I think that's important to explain as well. Okay, because I think that if I'm right and natural selection is not explanatory, right? It's not a big deal, and I think that will, I guess, lower the anxiety of what's going on here. What's at stake? What do you want to do?
I mean, whatever you think is necessary, I guess.
Okay. Given that there's so many people watching, I think they should know the argument that we're talking about. But I'll start with what happens if I'm right, and then I'll go to the argument. Okay. So I think, like I said, if we ask the questions, let's look at the Galapagos. Why is it that these birds have in this island have larger beaks? Okay. Um, I think you can paint a very brilliant explanation for that. All right, Darwin did, right? You could say that they have larger, that the beaks were conducive to fitness, and insofar as that they could break larger seeds, and if they break larger seeds, then they consume nutrients, and then they are more likely to survive and reproduce. Okay,
Hmm.
that there's nothing wrong with that picture, right? But I think that number one, if you just say, "Oh, they have large beaks because of natural selection," that tells you nothing, okay? And or tells you if it tells you something, it tells you very little, okay? And the second thing is that I could just paint that story as exactly as the way I did without saying at the end, "And that's natural selection," okay? Or there is natural selection in that system, or there's some overarching theory of natural selection that is explanatorily relevant to that case, okay? So, in other words, every single narrative, right, that concerns the topic of natural selection with respect to why the allelic frequencies are that way, or how the ecological variables interacted with those frequencies, can be sufficiently accounted for without this appeal to this mechanism called natural selection.
But I never heard an alternative mechanism.
What is the mechanism for why the large beaks got are why is it that the large beaks move to fixation?
Fixation meaning become more common in the population.
Yeah, so from when a trait moves to fixation, you can think of it as like there's like a graph, and then suddenly it starts to plateau. So like let's say the phenotypic frequency is at 30%, and then it plateaus at 70 and it remains at 70. That's moving to fixation.
Okay, so we call that stabilizing selection or something like that. Um,
Okay.
so the reason that happens is because birds that have a beak of a certain dimension have, because they are better able to gain access to nutrients, have statistically better odds of reproducing. And so that allele frequency or that genetic composition, whatever that particular one, becomes more popular in the population. You will always have, because for any trait, this is another one of Darwin's premises, there exists natural variation within a population. And I don't just mean like total variation among the group for all traits. I mean within a trait. Um, so like, the birds that, like, we say the certain Galapagos finch has a beak this big. Well, actually there are several that are born, because you have outliers with beaks much larger and beaks that are much smaller. But the ones in the middle there, they have again, they are the best fit. So they on average have the most offspring, and their offspring statistically are most likely to be more like them. And so that's what maintains the numbers at what we see. That's what accounts for fixation, I guess. I've never used that term, but I actually kind of like it.
Yeah, I hope it's a technical term that I heard from another biologist. So I don't know if chat can tell me if that's used in evolutionary biology, but that's the term I use. Um,
So
so
do you think that we're saying the same thing in a slightly different way? Or do you think that what I'm saying is very different from what you're saying and not necessary?
I think where the disagreement is that statements where natural selection is appealed to as explanatory are problematic. So when we say something like natural selection explains why the large beaks move to fixation and rather than the smaller beaks, that statement is false
Why why is that?
because there
Because
is
I
no.
think I just laid it out.
I
Sorry.
think what I'm trying to do is that you asked, are we just saying the same thing? Like, are we talking past each other? Maybe we do it at the end of the day, agree. We're just using different terms or we have different conceptions of what natural selection is. And to show that we do have a real disagreement here is that for every statement that there is where natural selection is appealed to as explanatory and an ecology, I'm going to say that statement is problematic. You're not. So we do have a real disagreement.
So
Right.
the matter here, Peterson, in your explanation of why the finches have bigger beaks, you gave an explanatory mechanism that explains why the bigger beaks are more likely to cause survival, right? The bigger beaks mean that they can break the bigger nuts or whatever, and that therefore they don't starve as often. So that's a mechanism, right? There's a direct correlation between some phenomenon, bigger beaks, and some outcome, right? So in that sense, it's a mechanism. But you didn't have to say like the notion of natural selection doesn't have like that kind of explicit mechanism built into it. That's the contention here.
So
So this
is
would be
this
like
the
peak
whole
selection.
right? Is this the whole thing that there is no law that says select bigger beaks?
Not exactly. I gave you the warfare selection example. So why is it that in the Battle of Bunker Hill, a lot of English soldiers died rather than revolutionaries, right? And you can paint a perfect picture about the hill, the defensive structures, the color of their uniforms. But notice that you're not saying that there's a mechanism in the system that is warfare selection, right? We
Right.
can paint perfect pictures of what happened in conflicts where people are dying more frequently than this other type of group, right? Without saying that there's a mechanism in that system called warfare selection.
Um, sure. I think I know where this discrepancy sort of comes from, and it's sort of the first thing I lay out in my argument. But since we're already on the topic of like the beak thing, um, one of the contentions, and I heard you bring this up, is like, okay, look, the natural selection can explain why there are, like, why the beaks are. Well, I thought the problem was like natural selection can tell you why the beaks are like the size that they are, but what if the beaks also happen to be shiny? Natural selection can't. This is called the free rider problem. So it doesn't adequately explain why specific traits are selected for because it can't distinguish between a trait that is selected for and a trait that's like just a byproduct. Those are what those free riders are.
I'm not saying I think you get the gist. I mean, the point is that one of the person that gave this argument, Jerry Fodor, the reason why he's an atheist, by the way, and he's
Yeah, I know.
all right.
He believes in evolution.
Yeah, he believes in evolution. He just rejects natural selection. Just like basically, I take from him. Okay, he started realizing that statements about natural selection, we were treating natural selection very much like a mind. Okay, so when I chose to catch up,
Yeah.
you know,
And I think he's very wrong for doing that.
okay, well, it create. Okay, should I explain the intentional extensional distinction or no?
I think that'll just be even more confusing.
But that's the crux of that's the critical part
Yeah.
of the argument, because if it's intentional with an S, okay, not a T, right? Then it does have some it is analogous to mind. Okay. And if it's extensional, then it's not analogous to mind.
Mm-hmm.
Okay. But let me explain it. You see, okay, I have to do it. I have to do it. There are 500 people watching. They're going to be confused if we don't explain the argument. I'll be as brief as possible. So this is essentially
Sure.
Fodor's argument, okay? There is a distinction in logic, linguistics, and in math called the extension-intension distinction. Now, it's very unfortunate. It's not intention with a T. It's intention with an S. Everyone can look it up. It's a legitimate thing in logic, math, philosophy, language, okay? It's not really a scientific concept, okay? It's an abstract concept, okay? And so causation, certain forms of causation are extensional in this kind of way, okay? If Superman is stabbed by kryptonite, given that Superman and Clark Kent are the same thing, you can take the term, the name Superman, replace it with Clark Kent, and it's still true. So if Superman gets stabbed with Clark Kent, if Superman gets stabbed with kryptonite, then Clark Kent gets stabbed with kryptonite, right? So you can substitute the terms. I guess a scientific example is if a red copper ball, okay, falls on the floor, right? Well, we would say that the red ball hit the floor. Given that the red ball is the same thing as the copper ball, okay, then the copper ball would also be hitting the floor, given that the red ball and the copper ball are the same thing. So with extensionality, you can substitute co-referring terms, and it's always going to be true, right? If you slap Danny, you're slapping Planet Peterson's guest underneath Blitz, right? You could substitute. That's how causation usually works. But there are cases where there is no such context, and we call that that context an intentional context with an S, okay? So examples of this are usually good examples of them that are very obvious are cases of where we're talking about minds. So Lois Lane believes that she's dating Clark Kent. If you substitute Clark Kent with Superman, it doesn't necessarily preserve truth value, because Lois Lane carries what we call propositional, or we could just, to make it easy, semantic content, such that she is sensitive to various co-referring descriptions like Superman and Clark Kent. She can tell the difference, right? Such that it's not necessarily true that if Lois Lane believes that Lois Lane believes that she's dating Clark Kent, that Lois Lane believes that she's dating Superman, okay? So
Because she doesn't know he's Superman, right?
Right, because
I think she actually does, but we'll just say she doesn't.
Yeah,
I don't remember.
At some point, I think she doesn't know, right?
Yeah.
So this is called the intention-extension distinction, and sometimes they call intentional context as opaque context. You can look at that too. All right. So the problem that Fodor had is that he realized that natural selection creates not an extensional context, but an intentional context with an S. Okay? Because here's the example that I gave to Peterson last night. Natural selection explains why the large beaks move to fixation. Okay? Now the large beaks are identical to the shiny beaks because the beaks are shiny. Okay? So the large beaks and the shiny beaks co-refer, just like Superman and Clark Kent co-refer. Okay? Yeah. So when you take the statement, natural selection explains why the large beaks move to fixation, and you substitute natural selection explains why the shiny beaks move to fixation, that's a false statement, right?
No, it's not. And I can tell you why it isn't.
Okay, go ahead.
Sure. So this is the free rider thing. So I have a funny example. So let's say that people who are immune to super buttworms also have no fingerprints, right? Not having fingerprints isn't helping them survive, and so natural selection can't tell us why that trait is being selected for. Does that make sense? I wrote this ahead of time.
You brought up
so-
what the free rider problem, right?
Yep.
Okay, yeah, that makes
Yes.
makes sense to me.
So, this is why this is false, because free riders are selected for because they are linked to other genes. So, like, we can think of it this way. If the free rider is baggage to the gene being selected for, then the gene being selected for is also the baggage of the free rider. So, in other words, that even an irrelevant characteristic like that the beak is shiny still provides an evolutionary advantage. So going back to my example, yes, having no fingerprints does predict how likely you are to be immune to super buttworms, right? And this concept of gene linkage, what it means, do you know what gene linkage is?
So I think that on chromosomes, right, there are going to be genes that are like on the same. Is it loci? Is that right? Or
Yeah.
Okay.
It's genes that are very close together.
Right,
Some
okay.
aren't very close together, so they're not highly linked. Some are like neighbors, so they are very highly linked. And that was discovered in 1910. And then there's also Dmitry Belyayev's, very hard name to pronounce. I'm probably getting it wrong, but do you know about his domestic fox studies?
No.
So those became world famous in the 1970s. And I'm pretty sure Fodor knows about both of these things. So I really thought it was kind of weird that he would argue this. So let's think about, here's some really interesting things about domesticated animals that you knew, but you've probably never thought of before. For example, they have floppy ears, right?
Yeah.
They have curly tails. They are piebald, which is the tendency to have spots rather than a coat of many colors blended together, right?
Mm-hmm.
They tend to have small snouts instead of like longer snouts. That's especially true like for dogs, domesticated dogs. So those things have nothing at all to do with the goals of domestication, right? Domestication is completely, well, not in all cases, but it's about tameness and
Cuteness.
cute. Well, the cuteness thing comes with some of it, but like for cattle, for example, they're not really selected for cuteness. They're selected for milk production or meat production, but some tameness is going to go in there too, because the Cape buffalo has never been domesticated and never will, because it's just too goddamn ornery, as some would say, right? So Dmitry Belyayev, he took a bunch of wild foxes, silver foxes, and did this domestication study, and they had an extremely simple concept. When they tried to feed it with their hand, would it bite the hand that bit them? That was basically the only metric. And so what they did was, with every litter, they would, oh, seriously? God damn it. Hold on, give me 1 second. My camera just died. I got to replace the battery.
No problem.
We can see you.
Sorry, everybody. Technology. I've had 2 technological malfunctions.
Have you?
in one live stream.
TikTok's been glitching a ton recently, right? Like, is it just me? Like,
Nah, my TikTok's been fine.
Your TikTok's been fine. No, then you're just spared, right? Like, I've been dealing with
The TikTok gods hate me, so I don't know what you're talking
Yeah,
about.
that's true. That's true.
Wait, are you glitching too, Blitz? I mean, I've been glitch.
I don't believe in curses, but
No, I just have a technical issue, but it's my phone, not TikTok, I think. It just disconnects my Bluetooth headset every time I bring a new guest on, which is very confusing.
So anyways, the domesticated fox thing. So the only metric they really used was will it bite the hand that tries to feed them? Well, so they would have the litter of pups, and then the ones that were the most friendly, they would allow them to they would continue breeding those ones, and they would turn the other ones into scarves or something. I'm not really sure what they did. Now, what they found was, yeah, they became more tame over time, but it came with a ton of other traits. They started to exhibit the characteristics that domesticated pets and livestock have. They had the curly tails, they had the floppier ears, they had the smaller faces, they had they actually started to whimper, which foxes don't do that, or like whine or whatever you call that. And their coats became the colors of the hairs in their coats started to pull apart to become closer to that piebald thing. So I think that actually natural selection does account for those free rider things because they are linked. This other thing's actually a different point. So that's what I would say in response to that free rider problem. I don't think it actually is a problem.
Okay. So it depends on how you're. First of all, it sounds like you're saying that for every free rider that is relevant to natural selection, that it does have properties that are conducive to fitness.
Well, it has unintended properties, I guess, because like the trait in question is the free rider of the irrelevant characteristic as well. So the presence of that irrelevant characteristic does predict this other trait, not perfectly because they can be separated. But I mean, inheriting a gene for a positive trait is no guarantee either because there's always variation within the population anyways. Some traits really are like, yeah, you will have blue eyes if you get this allele, but others are more complicated than that. Well, actually, almost all are more complicated than that.
The point that so with the beaks, right? So I use shiny beaks. The shiny beaks refer to the large beaks. The reason why I'm using shiny beaks is because I presumed that the shininess of the beaks aren't conducive to fitness. Now you're saying they're
not harmful necessarily,
but are they conducive to fitness?
No, they're free riders.
Okay. So then natural selection cares about which one, the free rider or the trait that is being selected is going to be the one that's conducive to fitness.
It cares about the size.
You're right.
I mean,
right.
the other thing could be relevant for reasons we don't know yet, but we're just asserting that we have absolutely no. Well, I don't know. We could take birds. We could prove it. We could take birds and paint their beaks red, or capture birds and like sandpaper their beaks so that they're rough, and notice no decreases in fitness, hypothetically.
Right. Okay, so that just shows that natural selection is operating on the large beaks, not on the shiny beaks, the shininess of the beak.
Well, in this example, we don't know why they are shiny, I guess. I tried to give you. Sorry, what?
I don't think we have to know why.
Well, but knowing why would, like, if they are linked genes, then we would know. Then we would have a fix for that, for example.
Okay, so the statement that natural selection explains why the shiny beaks move to fixation is just as true as the statement as natural selection explains why the shiny beaks move to fixation.
You said the same thing twice.
Yeah, you said the same thing twice. So big versus shiny.
I meant to say the first one was supposed to be large beaks. So the statement natural selection explains why the large beaks move to fixation, right? It's just as true as the natural selection explains why the shiny beaks move to fixation.
If they are linked, then it would explain it very well. Not perfectly because they can be separated, but the trait we're interested in is a free rider of the irrelevant trait. Now this beak one is made up, so we can't really say one way or the other. But what I intended to show was that a free rider trait can be accounted for. Now we don't know how many free rider traits there are. There's presumably a huge number of them, but I'm just saying that evolution can account for it.
I'm not saying evolution can't account for it. I'm saying remember, I think you can explain these things. I just don't think natural selection does any of the work that it's said to do.
Oh, well, I for gene linkage and well, I mean the thing with the domestic foxes, I'm not even sure if those were linked genes, or if they were just simple, because genes have single genes are they can be pleiotropic, which means that one gene actually has more than one effect on the organism. It's not just the case that this gene does nothing other than X, whatever X is. It actually has multiple effects. So I haven't brushed up on my fox genetics
Okay, well, I think we
ever,
can actually circumvent.
but actually, well, just real quick, the domesticated fox thing, the selecting for that behavior does end up explaining why they also have those irrelevant traits like the piebald coat and the floppy ears or whatever. You don't necessarily like I can't necessarily point to you in the genetics where it's happening because most of our traits are polygenetic and it's a symphony of gene expression and it's wildly complicated. For example, human height is the most significant gene variant we can find for human height accounts for like something like it's less than a it's way less than a fraction of an inch even, so you can't find something for it. But I think you can explain why these traits end up that way based on certain other traits.
Okay, so
They're
I think
just
I can.
natural consequences of it.
I think I can illustrate the problem without appealing to like gene linkages. So take this example. Okay, so let's say we have a wild flock of parakeets in, let's say, in Costa Rica, and we say, let's just say that there are two colors. Okay, we have the blue ones and the green ones. Okay, now my wife, her favorite parakeet is the she likes the blue ones. Okay, now what we see is that, oh, I'm making up this example, but it's realistic. Okay, what we see in this population of parakeets is that over time, the frequency of the blue ones lowers to 30%, and then the green ones, of course, then accounts for the rest of the 70%. Okay, now we might, let's say that the evolutionary biologist looks into the problem and then makes the statement, natural selection explains why the blue ones are dying off more than the green ones. Okay, now the blue parakeets are my wife's favorite parakeets. Those are co-referring terms, right? The blue parakeets refer to the same stuff as my wife's favorite parakeet, my wife's favorite set of parakeets in that population. Okay, but it'd be very silly to say, right, that like natural selection explains or operating on my wife's favorite parakeets, right? It's so, because it's silly to say that, it is suddenly creates an intentional, with an S, not a T, an intentional context, right? It's not extensional, because it seems like what you're suggesting is that claims about the explanatory power of natural selection are actually extensional. But this case shows that it's got to be an intentional case, because natural selection is not operating on the my wife's favorite parakeets, it's operating on the blue parakeets.
Literally all of that went over my head, and I tried really hard. I'm sorry.
Okay, so
Um,
no, it might be
I
my fault. It might be my fault. Do you want to say something, or do you want me to try to re-explain it?
well, I think I was gonna try to get into what I think like fundamentally Fodor doesn't really get about evolution. Um, and it does go on for a little bit, but that's what I would like to do. I have a hard out of here in 30 minutes is the other thing. And it won't take me 30 minutes to go over this, but is that okay with you?
Look, it's your live. Whatever you want to do.
That's true. I'm special. Um, uh, so I think one thing is like we hyperfixate on these traits, like the beak, its size, and its shininess, but natural selection doesn't select traits; it selects genes, right? So there's an example. I watched a YouTube lecture last night where they talk about for like hemoglobin, the heme is selected, but not the fact that the heme gives off the red color, right? There,
Can I
so
interrupt for a second?
yeah.
Just clarifying question. So Darwin had natural selection wrong because
No, because one of the embedded assumptions is that uh, what is responsible for variation within a population is heritable. Now, he
when
didn't know
Darwin
that genes existed, but he didn't say, because if we say that natural selection selects traits, then Lamarckism is true and Lamarckism is false.
but Darwin thought that natural selection operated on large beaks. Is he wrong for that?
No, because his argument was, I think I just said this. He and we talk about this in imprecise terms. We do this all the time as a science teacher. We do this with literally everything because otherwise it's too confusing. But again, one of the basic premises is that whatever is responsible for the characteristics that shape organisms, because there's variation within the population, whatever that is heritable. Now, he didn't know that it was genes. And I mean, I don't think, like, you're not arguing with Darwin, you're arguing against the modern synthesis of evolution.
No, I'm arguing that Darwin didn't discover anything that is natural selection. That the modern synthesis adopts a part of the adaptationist program that comes from Darwin, right? Darwin is said to discover natural selection, and if you're saying, well, it's a misconception to think of natural selection as caring about traits or operating on traits. Well, that means that Darwin was mistaken when he was saying that natural selection operates on traits. He was, maybe later on we corrected him, but I didn't think we corrected him on that.
To be clear, let's
I just
acting
don't
as a middleman.
agree. Yeah, go
What
ahead.
do you mean by operating on?
Yeah, that natural selection explains why a trait moves to fixation rather than, and he's saying, well, no, it doesn't explain why traits move to fixation. It explains why alleles move to why their frequencies change.
Yeah, I think that the modern understanding,
Well, it explains both but it's operating at a level that we don't think it does. We think it selects for traits, but it's selecting for genes, but the results are the same.
Okay, but is it a false belief? Go ahead, Blitz.
So it sounds like so just to summarize, I think that the idea is that if we think of natural selection as some sort of black box, it takes in as inputs traits, and it spits out preferred genes. Would that be a correct way of thinking about this?
Are you asking me?
Both of you. Does that line up with with either of your understandings of the mechanism that natural selection operates here?
It takes in traits and spits out genes? No.
Yeah, so there's like a trait that, like the big beak trait versus the small beak trait. If the big beak trait is, survives better for whatever reason, that means that the gene that codes for that big beak trait is now selected for and moves towards fixation.
I don't think it's, I mean, I did not get very far, and so I addressed this, but it's not because of the beak. Not really.
Well, the thing about that, Blitz, is that that's compatible with thinking that natural selection explains why the beaks and not merely just the alleles, because there's a transitivity of explanation, right? Like, if natural selection explains the allelic frequencies and the allelic frequencies explains why there's one phenotype over another, okay, then it's going to be transitive. Then natural selection at least causes or explains.
Sure. Yeah, no. My only point is that I think that I think that both of you are talking past each other with regards to genes versus phenotypes. And the important point that I think, and I could be wrong here, my understanding is that Darwin basically made the observation that, hey, whatever is causing the beaks to do their thing, that's what's selected for. But he wasn't worried about genes or what was doing it. He just knew that there was that it was the beaks that were doing it was the fact that there were beaks that were big or small or whatever, and it wasn't the fact that there was some particular protein arrangement, right? Like what's the word? The proximal cause is the beaks, not the genotype, even though there's a direct link.
Clarifying question: does natural selection select for traits?
Well, a gene can be considered the trait.
Okay, does natural selection select for phenotypic traits?
That's how we talk about it, I guess.
But we could be wrong.
That's like what we
Well, what
say.
is the fact of the
Organisms
matter?
that possess these phenotypes have better reproductive success in their environment, and therefore the population in the future
Because
will
you're trying
be
to
a
correct
reflection of
Fodor.
that.
You're trying to
Yeah.
correct Fodor in saying that, look, it's a misconception to think that natural selection selects for phenotypic traits. It's really the the alleles that are relevant here. But if that's true, then we would be wrong to think that natural selection selects for phenotypic traits, like big beaks.
Um, like uh, like this person in the comments just said, like consequently, yes, but um,
Where are you saying Fodor gets wrong about natural selection that you were trying to explain earlier?
well, well, I'm gonna have to jump ship then, and I can go back to the gene thing earlier. The thing that he seems to get the most wrong about it is that with this mind analogy, to say that, well, natural selection must possess characteristics of a mind. Um, the problem with that is that natural selection isn't active; it's passive. It selects against traits, or in other words, like it's a filtration mechanism, not not a mechanism that has any sort of intention or whatever. So like this is what I was saying earlier. We describe things in imprecise terms, and it's unfortunate, but we kind of don't really have much of a choice because, like, this is just how science communication works, I guess. It's like, for example, when I have my students draw electrons in energy levels around the atom, uh, the Bohr planetary model is like it's not correct, but it is still accurate in certain ways that are important and useful. So if I told them, if I tried to teach them how to get this stuff in the way it really works, then we would never get anywhere because it'd be too confusing. But anyways, that was just kind of a little side thing.
Well,
So
Fodor is saying. Oh, go ahead. That was a side thing. Go ahead.
yeah, so this is a Galton board. I don't know if you know about these, but so there are we could argue there are more and less favorable outcomes on a Galton board because it creates a normal distribution here, right? So more and less favorable outcomes. Hopefully you guys, it's really shiny, but you can kind of see that. Um, those outcomes are predictable, but never perfect. Like it's within the realm of possibility that every single ball ends up way over here. It's just really not very likely to happen. So the board doesn't select for the balls to go anywhere. Instead, it just filters them. So there's no
What's the mechanism in the filter?
what well, it's just simply it's just the odds of what is going to happen. So like there's no intentionality there. The pieces are simply in place, and probability theory predicts where they will end up. Now, the reason I'm bringing this up is because, in my mind, nature is these pieces that are in place. No effect is predetermined. The effect is only determined after the events have taken place. Reproduction doesn't occur until after filtration has occurred. So it's not a there's no it's not a mind intentionally selecting things. So like we
Okay.
would ask, like,
So
how can
when
blind forces produce an outcome? And that's because, well, natural forces guide processes in that direction by just following their own rules, I guess.
Yeah, so interestingly, Photo brings that your exact example, the filter example, right? I think from what I remember, I think gumball filters or some kind of filter of those balls, right? That you so it's
Plinko
actually he uses that
from
example to show that like if you had multiple kinds of those devices of all of variants where there's all you have is some kind of filtration thing, right? Where you have something that goes in and something comes out, right? And there's only certain things are being selected through the filter, okay? That what natural selection is supposed to do, or what the way that it's purported to explain, is that number one, it's either a mechanism that's in each filtration device, such that when you say natural selection, you're referring to a specific thing in each filter, or it's a theory that overarches every single device, by which there are laws of what goes in and what goes out. Okay, and so if I took a lot of these machines just like that, and all we know is that there's ins and there's outs, and we ask the question, what is the mechanism by which, what explains why you get these outputs rather than these other outputs? It's not an adequate solution to say, well, because of the filter, right? The whole question is why one set of distribution rather than another set of distribution. And so now you've got to go into the filter and explain individualistically what happened and why you have a certain set of outputs. What Fodor's denying is that there's any universality of these filtration devices, either in the filter or an overarching theory of, that carries semantic content. Like an example would be like, for any red ball, no red ball will pass through these filters. And so when you see all the outputs and you ask, why are there no red balls? Well, then you can just appeal to that theory, right? So Fodor says it fails on both levels, right? It doesn't do one or the other. So he uses that example to try to illustrate his point. You could respond to that. I had something else to say, but I forgot.
Okay. To the degree that I was able to follow you, and that's not an indictment on your argument, it's an indictment on me and what we think of things in different types of terms. So this is why I wanted to bring up the gene thing. So I'm gonna have to just basically lay this out. So, like if we think of it's not the traits that are being selected for, it's the genes, but you can call the gene the trait being selected for as well. So there's no law that selects for big beak or whatever, for example, because evolution is really just chemical evolution. A bird does not pass down a beak. If that were the case, then Lamarckian evolution would be true. But we know that Lamarckian evolution is false. Organisms pass down genes that control for traits. So Richard Dawkins, the real reason he's famous is not because of the God delusion. He's famous because he taught us how to think about this in that way when he wrote The Selfish Gene. So an example is a chicken is just an egg's way of making another egg. So that's a cute analogy that people use, but it's actually true because the chicken does not survive, but the egg produces additional eggs, right? But we can dive down a level deeper and say, well, a shell is a way for the genes inside of an egg to have better odds of being copied and passed down. Each gene produces effects that statistically increase their odds of continuing. And if a gene produces outcomes that increases its own numbers, then it passes the filtration mechanism for evolution. It doesn't matter what it does or doesn't do, as a consequence of that, these emerging phenomena. So, viruses do this, COVID, for example, it turned into many variants. Some were less lethal than others. Some were more contagious than others. Some were upper respiratory versus lower respiratory. But there's nothing selecting for where the virus ends up, in your respiratory system. And that's because, I don't know. I lost my train of thought there for a second. But the way evolution really works is Richard Dawkins, one of his other really good books, is that it's a blind watchmaker. It doesn't seek out with intentionality that we're going to do these things. It's a blind. The process is blind, but it still realizes those characteristics or whatever. You're muted, Danny.
Oh, well, that was probably good because I felt bad about interrupting. Fodor doesn't think that natural selection is intentional with a T, right? And It's intentional.
Well, I'm saying, I well, go on.
Okay, but look, I think that the filtration, I think your filter example really illustrates Fodor's problem, right? Because like, if I show you like, um, there are a lot of filtration devices, okay? And let's say there are a lot of filtration devices with respect to gumballs, okay? There could be really complicated ones, there could be really simple ones. And so let's say you wanted to develop a theory about why certain gumballs get through the gumball machine and why others don't, okay? And maybe usually I guess gumball machines like actually don't select at all. They just whatever is the first one in that hole. But let's just say that there is these gumball machines that filter certain gumballs and not others. Okay. Now, when we ask the question, okay, why? Why is it that certain gumballs go through and not others? Okay. What I'm saying is that you have to look at each gumball machine and go for a specific individual explanation about that filtration system. Okay. That there is no unified mechanism across all filtration machines, nor is there a theory that governs filtration machines and gumballs, right? And so if you were to ask, okay, here's a gumball machine right here, the red one, only red ones went through, okay? And and you asked me, Danny, why is it that the only red ones go through? Oh, because of gumball selection. You giving me that, gumball selection explains why the red ones go through and not all the others. That says, number one, nothing about what you're trying to ask me for. Really, you want to get into the machine and give an exact individual account as to why red gumballs only go through, and notice that that individual case explanation that you offer won't necessarily apply to other gumball machines. But in every gumball machine, there is still a filtration process. It's just there's not a mechanism, nor is there a theory of gumball filtration.
Well, okay, so like for this thing, I would say, like we could say gravity is the mechanism behind like why the balls go from top to bottom, but then the placement of these pegs and like probability theory or whatever, I don't know if that's actually a term, describes why they end up where they end up. Right?
But it's a selection process.
Why we get this pattern? Why do we see the patterns we see in organisms? Well, I think there actually isn't there a unifying force guiding that? Because if we think about it from the level of genes, like we can create like autocatalytic reactions with molecules that actually compete against each other. Now, they're not living cells or anything like that, but like the laws of chemistry and which system is better able to reproduce those chemicals and I don't know I'm not going to try to use technical terms because I don't have an education in that, but whatever natural forces behind governing how those chemical systems operate are the same laws that govern how the chemical system of the cell operates, and it's going to carry through and manifest those traits as well. But those traits are just emerging phenomena of the genes themselves, which are chemicals that are competing in order to perpetuate their own numbers. Someone gave this objection to
Fodor. He's like, basically, aren't there unifying explanations in chemistry and physics with respect to the selection process? He said there very well could be. The point is that there are none at the biological level. You could reduce everything, all the gumballs and all the filtration mechanisms to physics and chemistry, but at that point, you're not giving a biological account of selection. You're giving some other, because the natural selection, if it were a theory or a unified mechanism, is on the biological level. It's not supposed to be some physics explanation or some chemical explanation.
Oh, well, people like Blitz a chemist would tell you there's no such thing as biology, it's all just chemistry. And then a physicist would tell you there's no such thing as chemistry, it's all just physics. Blitz, am I correct?
Yes. However,
yeah.
Well, but the point is that so I think the objection with regards to the Galton board is that the analogy of using natural selection would be something like saying, oh, there is some overarching law. Like if you imagine you have the Galton board, but you have different peg arrangements. You have a whole bunch of them, whole bunch of different
Right.
peg arrangements, but you can't see the peg arrangements. You can only see the distributions at the bottom. The analogy with saying natural selection caused these various distributions is saying there is an overarching phenomenon that, like an overarching ball-based phenomenon that there is that's causing. In this case, it's causing that you have a left bias distribution. In this case, you have a middle bias normal distribution, whatever. But a physicist would come in and say, "What are you talking about? There's just balls bouncing off of pegs, and then you have the law of large numbers." But the point is that the natural selection biological evolution, the ball-based evolution, is a non-explanation because it can't actually tell you if somebody gave you a different set of pegs. They can't tell you what the outcomes will be if you can't see the pegs.
Yeah, that's right.
Or rather, no, I should rephrase. If you only see the pegs and you don't see the distribution, without actually doing physics, or in this case physics, you can't tell me what the distribution is going to be. There's not like a law of peg arrangements.
Take the gumball example. Take the gumball. So look, if you're asking, Danny, this gumball machine only spits out red, doesn't spit out any other color, okay? When you're asking me for that explanation, you're not asking for a physics, for the laws of physics that explain why everything bounced off the gumball, inner workings and stuff. You're asking, is there some engineering structure in the gumball machine? And if there is, why is it picking out red ones and not the other colors? And so you're asking about the engineering of the mechanisms that are built into the machine. You're not asking for a level of science that you don't want to reduce everything to physics there when you're asking for that kind of explanation.
Okay, so I heard two different things. I thought what I heard Blitz say was, if we rearrange the pegs, which for natural selection would be, if the environment changes, we can't predict what traits will manifest in the population. Was that accurate, or is that accurate or inaccurate?
Roughly, without knowing what the roughly. There's not like a formula that you can plug the peg arrangement into to get out the distribution.
Sure. Now I guess I just don't see how, because I can't predict what it is, that doesn't mean that nature still isn't the filtration mechanism that's determining which characteristics become more prevalent in the population.
It is. It is nature. Nature
And Photo would say it's nature too. It's just the level of explanation is not utilizing biological placeholders. It's using he's fine to say that you can explain everything away using chemical and physical physics placeholders like electrons, atoms, quarks, or molecules. But the biological placeholders of genes, specific traits like beaks and stuff like that, those won't exist in your explanation if you're going to give a physics account, right? And I guess the last, and this is my last word because I know you have to go. Suppose someone asked, why is it that Harvard admissions only are letting people that have 3.9 GPAs into their college, right? In principle, you could give a physics explanation for that. You could talk about all the neural inner workings, and you could dumb everything down to quarks or whatever the fundamental particles are. But that is not what you're asking for. You're asking for a kind of explanation that has mental state placeholders about intentions and stuff like that. You're asking about placeholders that are relevant to doing well in school, not like how it all reduces down to the quark level.
I mean, I guess, but I feel like if we're saying that, then we're just picking nits. I mean, is Newton's law of universal gravitation false?
That's a good question for a physicist.
I would say no, precisely because
but it doesn't explain the curvature of space-time.
Oh, well, so if you mean, is it false in the sense of does it account for all predictions, then yeah, of course. But we could then say GR is true or something like that. I was actually going to use this as an example. But so the point is that Newton's law has even if it's wrong, if Newton's law was correct, if it did accurately match our universe, we wouldn't need space-time. And we could just say, well, there is this mechanism, whatever it might be, maybe we don't know what it is, but there is some direct causative link between mass and gravitational pull. Whereas I would say that, and this is the argument that I gave Danny, which is why I'm not quite on his side, but I'm leaning on his side. Whereas natural selection seems more like the second law of thermodynamics, in that the second law of thermodynamics doesn't actually give a mechanism as to how entropy increases, right? It just says that it does, and basically it's probability that makes it happen. It's kinematics and chemistry and all sorts of, there's like the actual mechanism that takes a low entropy state to a high entropy state is very complicated and doesn't have anything to do with thermodynamics on a grand scale. Rather, the second law of thermodynamics is kind of a name that we give to the collection of all of these phenomena that lead in a certain direction. Right, and so I would say that like natural selection is the name that we give for like beak selection and fancy hair selection and camouflage selection and all of these things. Natural selection is just the name that we give to all of those specific selection events or specific selection phenomena that we give. And so in that case, natural selection would be extensional, meaning that we are calling what we are calling natural selection is just a list of things that actually have some sort of deterministic, mechanistic procedure, if you will.
Yeah. So I think it's like really unfair to say that because, like, for example, because what I feel like I've heard is, well, because Darwin didn't understand that selection actually happens at the gene level, and there have been vigorous debates about whether like kin selection is a real thing and group selection is a real thing or whatever. I just think it's kind of unfair to say that because he didn't understand that part of it, that he didn't discover something. Because he discovered something that's very much true at a certain level of analysis. And that's why I brought up the example of Newton's gravitation versus Einstein's gravitation. I don't think one is false and the other is true. Not really.
Well, I might have looked. I think that was me responding to the idea that he has a misconception that natural selection explains or operates on phenotypic traits. I don't think that's a misconception. For if it were, then you'd throw Darwin under the bus.
I would say that Darwin is as responsible for discovering something as whoever discovered the second law of thermodynamics. Because what happened in the 18 whatevers is that, and this was true for entropy, it was happening around the same time, is that there was just this pattern observed in a whole bunch of different systems. And what I think Darwin deserves credit for is saying, look, this pattern is something, like there is this universal pattern of like these things happening. Now, Darwin couldn't list all of the types of things that happen, just like the guy who discovered the second law of thermodynamics couldn't list all of the chemical processes and atomic interactions and stuff like that make entropy always increase. But the point is that there is an identification of some sort of pattern. Now, I wouldn't call that a law in a causative sense. I would call it a law in a perhaps probabilistic sense. So that's, I don't know. I think Darwin does deserve some credit.
No, I mean, well, because I think he deserves massive credit because, I mean, even the people alive during his lifetime famously said, how incredibly stupid of us not to have thought of this. But I mean, you can take his basic assumptions even without knowing things about genes and make accurate predictions and descriptions of the world with it.
Okay, well, I mean, I don't know if you said you had to go, but
I mean, I can do a few more minutes, yeah.
Okay. Yeah, but I there's the intentional extensional stuff, which it's not fun to go through, but I mean, I still see my gumball analogy as being completely analogous to what's going on. And maybe that might be an easy way to think about the issue. And otherwise, I'm willing to go in whatever direction you want to go.
The gumball thing was it tells you why it goes where it goes, but not why the red ones ended up where they ended up.
So if you have all these really complicated, uninvented gumball machines, and they have different outputs, right? So it's one machine you look, and each machine represents a locality, an environmental locality in the biosphere or something like that, okay? Now there is a filtration. The filtration represents the explanation for why certain gumballs go through and not others. Okay. Now you can have certain filtration devices, right, that don't select any specific, don't select on the basis of any specific trait about the gumball. So this is supposed to be analogous to genetic drift. Okay.
Right.
So, and then you have some gumball machines that operate on a trait. Okay, so there might be gumball machines that scan for color. Okay, and so it only let the red ones in. Okay, so I just wanted to establish the analogy of what's relevant. So gumball machine to environment, filtration devices in terms of the selection process that goes on. There are some selection processes that are blind, like genetic drift, right? A landslide that depletes, 30% of a particular allelic frequency it's nothing to do with those alleles, right? So now let's just look at the gumball machines.
Well, that's
there is a
right, but that's not a problem for natural selection.
I'm not saying it is.
Okay.
Okay, I'm just saying we're going to take those gumball machines out of the picture because those gumball machines we're not interested in. They're not relevant to a selection process that's intrinsic to the filter of each machine that is sensitive to the traits of each gumball. Okay, so take a gumball machine that has an internal thing where it scans the color, and if it's red, it lets it through. Any other color, it spits it back into the holding cell. Okay, now again, so if you didn't know that, right, and you're asking why are all these red gumballs that are all the same size, why is it that those are going through the machine? And you ask me because I created the gumball machine. Okay. Or I didn't even have to create it. Let's say I discovered it. Okay. Well, we can look into the machine and see the scanner. Oh, it's going for only red ones, right? There's something, and you can give a physics description for that if you wanted. But we notice that there's nothing in the mechanism that counts for size. So the ride along would be the size of the gumball. The trait of interest would be the red gumball, right? Now we can perfectly explain all of that in that gumball machine. But then, when you're looking at the next gumball machine, okay, there's nothing that's going to be, in principle, there's nothing that could be shared between the two gumball machines in terms of what explains why some gumballs go through and not others. And that's precisely why natural selection can't be overarching. Just like gumball selection is not overarching because each mechanism will be different.
That didn't work for me at all.
Blitz, did you understand? Maybe you could explain it. Did you understand me first? And if you did,
yeah. I mean, the point is that natural selection doesn't refer to a single thing. It doesn't refer to a single idea. In the gumball case, it doesn't refer to a single internal mechanism that actually selects for the things. Rather,
so if you asked in the first gumball machine, Danny, what selects for it? And I just say gumball selection. Does that tell you anything?
Right. You have to look at each specific case, and you have to say, well, in this gumball machine, so like in the Sahara Desert, it happens to be that, if it's a red, then the scanner causes a little doorway to open and it falls through, which would be like, well, if it doesn't sweat a lot, then it survives more often or something like that, right? So the point is that for each specific situation, you need a different explanation. As far as the world is concerned, and as far as the gumballs are concerned.
While it's still true that for every gumball
but
machine,
nature's different in every.
Yeah.
Well, not on the level of chemistry and physics. Certain there are going to be contexts that you can have generalizable principles, right? But that's not the case for natural selection because there are no generalizable principles about selection.
If you try to analyze it from the level of the gene, I think that there is.
Well, give me one principle.
Well, I don't know. Blitz, maybe you could describe this, but what is the principle that governs the way that genes that are like chemicals that can be autocatalytic, the way they compete against each other? I wouldn't know what to call that. I mean, the reason any chemistry happens is because they're trying to like reduce their energy and try to maximize stability or whatever.
Well,
but now we're just saying, well, it's actually just physics. But
go ahead.
The point is that if you want to talk about natural selection from an evolutionary biology perspective, the point is that it kind of reduces to just like a collection of very specific explanations, like a collection of specific explanations to each particular case. On the other
Just
hand,
like in human history, just like when we try to explain human conflicts, why one party wins a war rather than another one, or why this president won rather than another, there's no generalizable principles of who wins elections, right?
unless you reduce it down to,
Physics.
electrons and stuff, and in
Yeah.
which case then you can say, well, there is Coulomb's law and there's quantum mechanics, and this is just a very
But then
complex
you're not doing
system.
biology anymore.
Yeah. So that's the point. That if you want to talk about, like, basically, can you write down a law of natural selection, like a formula for it?
Oh, well, I mean, you can write one down for evolution. It's called Hardy-Weinberg equilibrium.
Well,
Yeah, I mean, right. But that's fine. I don't know if that is
But that's not
natural
a-
selection.
that's not
though.
a
Well,
law
can
of
you
selection.
write a law for the weather?
No, that's precisely why there's no, like...
I would say yes. It's just physics.
Yeah,
It's just quantum
yeah.
mechanics.
But in terms of, like, I mean, again, unless it reduces to physics, I'm fine with, or chemistry, then there are, like, gas laws and whatever, but at the level of, like, that's what meteorologists have to do, is that they have to get into the physics of it, right? Or they have background assumptions about what typically happens when you have this kind of weather event and that weather event, and you combine it, just like you can predict who's going to win elections, right? But there are no laws of, like, weather, right? There are no, apart from physics, right? Which I don't even think in physics you have placeholders of the kind like clouds, right?
Weather's trouble. So one example of a biological law might be something like the molecular clock, right? That is like
Yeah.
given what we know about the world, you have like cosmic rays and random mutations, and so there is a direct mechanism by which, or like a law that says if you wait this long, you'll get this many mutations, right? So that would be an example of a biological law that doesn't reduce to physics necessarily, right? Like it's just like an observed A implies B in nature. And so I think the contrast is that you don't really have that you don't have the equivalent thing for natural selection. Unless by natural selection you just mean all of these individual laws for the specific cases.
Perhaps. I mean, I don't necessarily see that there's anything wrong with saying that natural selection is the consequence of these more fundamental laws. I still think that because I don't see how you couldn't argue that Darwin didn't discover that, and that counts as a discovery.
I think it comes down to the statements about when natural selection is invoked as an explanation. You and I disagree that the statement natural selection explains why these beaks move to fixation, let's say large or whatever. That statement, given Fodor's concern, if he's right, is not true, right? And so if that is right, then Darwin didn't really discover the thing that is supposed to do all the work of explaining why these traits move to fixation.
I just don't get that. Because we can explain where all of these traits come from. And
yeah.
so I guess I can't think of anything to say other than repeating myself, which is that Darwin discovered the effects of these more basic fundamental principles. Because, again, I said this a couple times, but he said whatever is responsible for these traits and characteristics is heritable. And he overturned the idea of Lamarckian biological evolution, which is that if you have a characteristic and you use or you overuse it or whatever, then it can be passed down. Now, he didn't know what that was. He didn't know about genes. He thought maybe it was these things called gemicles. That was obviously wrong and whatever. But, I mean, I feel like, I don't know. I literally have to go, but I feel like if we're going to say that Darwin didn't discover anything, then it's almost like saying evolution doesn't even happen. then,
No,
or
no,
something.
no,
I don't know.
no, no.
I just don't get. Well, but if
I didn't say he discovered
if
anything.
Darwin's theory is extremely
Well, let me
successful,
clarify. Fodor is not saying that Darwin didn't discover anything. He's saying that Darwin is wrong with respect to this concept or thing, mechanism, theory of natural selection as being explanatory in evolutionary explanations. Because he did give evolutionary explanations and they were good.
yeah. But I mean, what am I trying to say? I had it for a second and then it ran away from me. But like, if natural selection doesn't do anything, then what does anything? I mean, this whole time I haven't asked for what's the alternative, because I've just been trying to defend a worldview or whatever. But like, I can't imagine what the alternative even possibly could be.
Well, I think what's going on here is, look, I think that you're not understanding natural selection the way I think Darwin and others are, insofar as its overarching theory about all environments. Okay, it would be like, look, if the historians invented this mechanism called warfare selection, and I say, what is that? How does that help you explain why the Bolsheviks won over the Mensheviks, right? And then the response that they would give, that you just gave, would be like, okay, well, if it's not warfare selection, then what could possibly explain why the Bolsheviks won out against the Mensheviks in early 20th century Russia? Okay, and the point is that the explanation is in that context, and that explanation doesn't necessarily extend to other contexts.
I don't know. I think the principles of natural selection do apply in all environments.
Do you think the principle of warfare selection applies to all wars?
I don't know what that is, so I can't really give. I'll
tell you exactly what warfare selection is. Watch this.
I'm 100% sure I don't have time for it. I'm sorry.
Oh, okay. Well, I appreciate you having me on. For the record, I was invited to the detriment of the audience that are tired of the topic. I warned everyone. What I'll do is I will host a live on my backup account, because I don't like talking about this stuff on my main account, because I mostly attack Christians. If you want to talk, anyone can come up. It'll be an open panel on Danny Dawa, Dawah. That's my backup account. And for anybody that wants to talk to me, or maybe even agree with me, say or disagree with me that on this topic, I'll be more than happy to let up. Thanks for having me, Peterson.
Likewise, go have fun with your thing. Go have fun with your thing, Peterson.
Thank you. I will. And watch out for butthole worms, everybody.
Always.